Hello everyone. Welcome to the TTP LeetCode Workshop. My name is Jared and I'm a CS mentor and I'll be one of the hosts for today.
Hello, everyone. My name is Buddy Agumba. I am the lead data mentor and peer mentor for EEs and CEs. I'm also co-host.
And so let's just get started. I'll share my screen. So here are some of the topics that you might come across during like LeetCode problems. To start out with, LeetCode is a platform where you can type in data structures and algorithms questions. They're usually asked during coding interviews. And so LeetCode is a good way to practice those times. There's topics like hash tables, arrays, binary trees, heap stacks, queues, and so on. If you haven't taken CS 141, I would highly recommend that you take that course as well, because it covers a lot of these topics in depth. And there's also a couple of books I would recommend to go over as well to understand how to solve these problems if you prefer like the book route instead. There's Cracking the Code Interview and Elements of Programming Interviews in Python. These two books have helped me understand some topics that are covered during these problems. And then there's the Blind 75 LeetCode Questions, which are the problems that most other LeetCode problems are based on top of. So I've heard as long as you can solve most of these, you can pretty much solve almost any other problem as well. To start out with, we'll be on like the homepage of the LeetCode website. You can see like a timeline of a certain feed and like posts as well. And then, so we'll just go to the problem section. So here you can see like all the problems and like any list of problems you might put together, but some of them are created as soon as you sign up for LeetCode. The difficulty of the problem, easy, medium, or hard, whether you solve them or attempted to solve them, or whether you didn't do them yet at all. Topics covered in certain problems, so like you could filter for those if you want to only do like tree problems. You can sort for that, and then you can also search for a problem if you've been looking for like one that specifically. So today, I think I have it in another tab, but we'll do Twosome. And as our problem today, you can, I forgot. You can also, I forgot here. You can also sort for problems that have been asked about in certain companies, but that's only like a premium thing. So I haven't used LeetCode Premium before, so I'm not sure like if it's worth it to do it. But Premium lets you look at problems that are asked by companies and just companies specifically. So like if you wanted to look up like whatever problems like whatever problems Amazon have been asking, you can sort for that. And then they also have video solutions in case you prefer that as well. But I can't speak for it because I haven't used it before. So yeah, so today we're going to be going over Twosome. So we can read the instructions on the left. So basically it says, given an array of integers, nums, and an integer target. Return the indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. And you can return the answer in any order. So normally, during an actual coding interview, the interviewer might only ask these problems. I mean, this part of the question here, like just say whatever like basic part of the problem, and then they'll want you to ask questions to clarify how to solve it, just so they can see if you understand like whatever edge cases could be, like whatever edge cases there are in the problem, and just so you like they can understand your thought process of how to solve the problem. But since we're not in an interview, LeetCode's just providing it for us. We have an example input and output. So we have nums array, which has 2, 7, 11, and 15, and a target of 9. And then the output is 0, 1, and because 2 and 7, which are index 0 and 1, add up to 9. And they provide the explanation later on. And a follow-up, can you come up with an algorithm that is less than O of n squared time complexity? We'll get to that in a moment. Oh, and then also another thing, I'd say try to solve it when you're ready to solve the problem. I'd say time yourself for about 15 minutes. And if you can't solve the problem after that, try to look at hints or look at the discussion tab, which a lot of people offer like solutions there and then explanations of their solution. And so, and then also come back to the problem later, like 2 days later or so, something like that. Instead of solving it outright, just so you know that it's in your memory. So you know, like for later reference. And so also, before I start this problem, I'd encourage you to pause the video and try to solve it on your own. But I'll solve it right now. So we have to have numbers that add up to a certain target. So that means that there's multiple ways of doing it. So I'll do the first way right now. So you could just go through the list of nums. And just add up any possible combination except for like the same number. So I have to check if I does not equal j. Just so I know that I'm not adding up the same number. So here we're going through the list nums, and then we're going to it again. And then if it's not the same number and they add up to target, that means that we found the numbers that add up to each other, and you can just return I and j. But the problem with this one is if you look at the time complexity, you can tell that it's O of n squared or big theta n squared, well, depending on like which one you're using. But reason is because you're going through nums, like each item in nums here, and then you're going through it again. each time you go through one individual item. And so it adds up to n squared times. So there might be a way to do it more efficiently, and there is. So if you look at the problem again, instead of adding up each number together, I mean, instead of adding like each number together and just finding all possible combinations, there's a way to like solve it in, there's a more efficient way of solving it. And if you look at the related topics, there's a hash table involved. And so you could try to find a way that's more efficient using that. Oftentimes the topic section can give you an idea of what tools to be used, like what like methods are used in order to solve the problem in the most efficient way. And so here you can try by creating like a hash table that keeps track of the numbers that we found. And then later on, we could subtract from target, right? So for example, we could store 2 in the hash table and then subtract 9 from 7 later on. And if, so that'll result in 2, and 2 will already be in the hash table. And so that's how you'll know whether some numbers have been that you have like the numbers that will be like that'll add up to the target basically. And also we'll also keep the index of whichever number stored on the hash table, as well as like the value, and then the number itself will be the key. So we'll have like a way to keep track of both indices. So I'll just create a hash table first. And I'm going to iterate through nums. And at first, we're going to have to keep track of whether a number has existed in the list, like whether it exists. And then we're also going to have the index associated with it. It's stored on the dictionary. So now that we've been able to keep track of whether each number in the index, we'll have to also check if a number has been like if a number adds up to the one that's in the hash table already. So that means that we can check if target, I think it's target minus nums I is in the hash table. So just making sure that I'm doing this correctly. So we have the hash table, and then we're adding like a certain number to the hash table along with its index here. And then up here, we're checking if target minus the number is in the MySums hash table. And if so, that means that we have to return the indices. So that means that one of them is I, because we know this because we're passing through the list of nums, and the current number we're passing through, and so target subtracted from the current number we passed through is in MySums. And so in this current iteration, I should be one of the indices. And then the other one is stored on the hash table, so we have to retrieve it. And so I believe that should work. And it ran. And so if I run it, for all the test cases, it successfully ran. And then you can also like compare your solutions to other people to see if you had an efficient solution. So it's faster than 80% of other Python 3 solutions. So that means that it's probably efficient. And also, yeah, so we can tell this is O of n instead of O of n squared because we pass through each element once in the list until we like find the sum. Does anyone have any questions? No, so I guess we're good. And yeah, also I'll paste this link in the chat for like the topics, and anyone with a Riverside, like an RML account, should be able to access it in case they want to like review the topics. And I guess that's it. So happy coding.